Hi, so I've been working on an image editor project. I mentioned this in my last video. So today I'm here to document that. And I have reached my first checkpoint in this project. So I thought I would create my first devlog. So I hope you guys are able to learn something from it. Okay, so I have the project booted up over here, and what you're looking at is an image editor. So on the left side, we have a canvas on which we are rendering our image. And on the right side, you have a control panel. So this might look a bit different from my last video where I showed a demo of it, but I have improved the UI from since then. So in this control panel, we have three tabs: tune image, effects, and filters. So I'll just quickly demo it one by one. So in the tune image, we have some basic adjustments, and if I update the brightness, you can see it happening in real time on the canvas. And I can apply other things like contrast, temperature, and tint, and whatever you want to do, and you can see the changes are instantly applied over here. Apart from these, we have some other things like effects and filters. Right now I just have one effect, Gaussian blur, and in filters we have grayscale and edge detection. Now these are some heavy algorithms. I'll just show you. If I click on edge detection, this will basically highlight all the edges that it can find in that image. Apart from these, I also have a broken zoom functionality. So you can see the zoom controller on the bottom, and if I click on zoom in, you can see the image is zoomed in. We can go up to 150%, and we can go all the way down to 50%. So let's go to through the flow once. So on the control panel here, we adjust something or we add a filter. This calls the WebAssembly function. Basically it creates a web worker instance, and in that instance we are loading the Wasm module and calling the function, and it will process our image and it will return a new image, and that new image will be stored in the image state. And as soon as we get a new value in the state, the canvas will re-render and it will basically update the new image on the canvas. So that's how we get to see the updates. And WebAssembly is pretty fast, so all this happens really quickly. That's one of the reasons why I'm using WebAssembly over JavaScript. And if you want to know more, please check out my previous video. I have explained everything with proper benchmarks. Okay, so this is the basic architecture of how everything is working. Now I'm gonna take you through the code. Okay, so this is our project structure, and this is a simple white app, and here you can see the Rust directory, which is something different. And inside this I have just initialized a new Rust project using cargo, and inside the source file we have just a single lib.rs file which contains all our processor functions. So for example, let's take in account the first one, which is grayscale image. You can see this here in the filters. We have a grayscale filter, so this is the function behind it. Now whenever I click on the grayscale button, this control panel will go to the Wasm function. Now this is the Wasm function. It is now currently in Rust, but we will compile it down to Wasm. So what this function does is it takes the image data, the old one, it does some processing, and it returns the image data. So what we are doing here is we are basically iterating over the image pixel by pixel, and we are calculating the average of the red, blue, and green channels, and we are then updating that average in all the three channels again, and we are keeping the alpha unchanged because we are not playing with the opacity here. Okay, so this is a very simple function, and we have added a prelude called Wasm bindgen on the top of this function. This indicates that we want to compile this function to WebAssembly, and this function will be later on exposed to JavaScript. Alright, so how do we do that? Let's go into our terminal. I am currently in the Rust directory, and here we have a simple command. Wasm pack is the package that we are using to compile Rust to WebAssembly, and calling this command, it will probably take a second or so. Yeah, so in under a second it will compile it down, and you will get this awesome package directly over here. Inside this we have a couple of files. Now this is where things get a little out of hand, but please bear with me. So here you have the main file that we want to know is this rust_bg.wasm. If you want to refer back to this diagram, this is the Rust function we wrote, and we compile it to Wasm, and this Wasm file we can use that compiled down version of it through our React app. Simple. And how do we use it? So when we do this command, it not only creates a Wasm file but also creates a JavaScript file. So this JavaScript file is nothing but a wrapper function. So if you check out this grayscale image function, this internally is calling the wasm.grayscale image. So it is calling the function in this wasm file, but it is doing some extra things on top of that, which is type conversion, garbage collection, and memory allocation. The image data that we are passing, which is the original image before the processing, that image is an array of numbers, right? It is an array of integers, and that's the type our Rust function, our WebAssembly function expects. But since we are calling it from JavaScript, we have to take in account that the type that is used in JavaScript is different from the type that is used in WebAssembly, because JavaScript is a dynamically typed language and WebAssembly is a statically typed language. So we need to do some kind of type conversion, right? So that's what it does. It allocates the memory in the Wasm linear memory space, and it will create a pointer to that array, and it will pass the pointer its length and the image data itself. So you don't have to be concerned about any of this. All you have to do is call this upper function. It will do everything for you. So that's the beauty of using Rust and Wasm pack. If you do it with any other languages, you might not get this level of service. And the binaries that are created using Rust are also very small, so it's not it's basically a better user experience if the user don't have to wait for it to download for a long time. Alright, so this is how everything works. I'll go back again to this diagram. Now that you know how Rust and Wasm are working, let's go to the flow once more. So we have a function written in Rust. We compile it down to WebAssembly, and from the control panel we are adjusting something like calling the grayscale function. This will, when we click on it, it will call the Wasm function, and it will process the image and return a new image, and that new image will be stored in an image state. And as soon as the image state is updated, that image data will be passed on to the canvas, and the canvas will re-render it. Now there is one more thing that I want to show you, which is the image state and the web worker. So first of all, let's go to the image state. This is the TypeScript file which defines our signature of the image state. If I refresh this, you can see the first thing that we do is upload an image, right? So where is that image? Okay, so I have uploaded the image, and that image is now stored in my original image, and it is stored, the image data is also stored, and the image element itself is also stored, because we need this when the first time that we are rendering it on a canvas. Alright, and the second thing is something called current image. Now current image is nothing but the updated state of the image. So for example, initially when we add the original image, this will be null, and after we do some adjustments, like I increase the brightness, now you can see the brightness is updated. So that means that the image data for each pixel is updated now. So we will store that in this image data, and we have a type because we need to know what kind of adjustment has been done. So we have, right now we have three things: tune, image, effects, and filters. So the current image will contain type of tune image and the image data, that is the recent one after updating this. Now if I further update the contrast, then it will still be of type tune image, and the image data will be updated after doing both brightness and contrast operations. So this is how we keep track of the current image. And you might see something down here, apply and revert button. Now the UI doesn't look very good because I haven't gotten time to work on it, but if I click on apply, you will see it says that, are you sure you want to commit these changes? This will merge the active changes into history. Now if I click on apply, you can see it goes back to 0 values, and the image is now updated. So now what happens is, this current image again becomes null because we don't have any more changes to commit. We have already committed our current image changes, and the changes that we did will be stored in the snapshots. Now The snapshots doesn't have any use in the current state of the app, but in future I am going to implement a feature called history, where you can see everything that you have done to that image in your whole editing process, and you can manipulate that and basically save your history, because you can save that history and then you can apply it to another image. The same process can be applied to another image. So that's what I have in mind. So that's why I have something called snapshots. It's basically an array of the current image. So you can see this part is same and it's an array of that. So once this changes are committed, this will go back to null, and and that changes will be stored in snapshots. So this is how the image state is working currently. Now the last thing I want to show you is the web worker. So I'll quickly go over to tune image worker. So as I told you, we are using web worker because we don't want to block the main thread when we do a heavy computation. And the web worker, it contains a lot of comments right now. So all you wanna know is it exposes one function called adjust image, and this function loads the Wasm module, it initializes it, and it calls the batch adjust method. So this is a method I wrote in Rust to adjust all of these changes in one go. So I just iterate the thing once and I do all the changes that are required. So this is what the batch adjust method does, and that's it. That's the that's our image worker, and we are just that image worker. We are using a package called comlink to make the web workers easier, because we don't want to deal with signals and basically passing the data over to the main thread and all that. So we are just exposing this method and we are calling this method from our app whenever something changes, and that's how everything is working right now. So now again, if you go back to this diagram, I think after going over image state, the web worker and the Wasm Rust file, I think this should become a little bit more clear to you. So this is what I have till now, and I also have this broken zoom functionality. So let me just show you that. I'll refresh it again. I'll add that image back. Now if I zoom in, it does zoom in, so it seems like it's working, but I cannot move the image after zooming in. So I have to add a pan gesture, which I am planning to do in the next checkpoint. Yeah, so I hope you guys learned something from it. I know we didn't go into the code much, but this is a very huge code base, and if I have to go over this, it will literally take hours, and I'm pretty sure that my code is not that clean that you will understand it in one go. So if you have any questions, please I'll be happy to answer it in the comments, and hopefully I complete the second checkpoint quickly and upload the devlog for it as well. All right, I'll see you in the next one.